Hello class and welcome to this review on the section 12.2, Annuities and Application of Sequences. So a couple of definitions, yes. An annuity is a sequence of equal payments made at equal periods of time. An ordinary annuity is each payment is made at the end of a period, aka compounding. A payment period is the time between payments. Term of the annuity is the time from the beginning of the first period to the end of the last period. And the amount of the annuity is the final sum on deposit in the account, which is the sum of the compounded amounts of all the payments compounded to the end of the term. So, as an equation, the amount of the annuity, S, of payments of $R each made at the end of each period for n consecutive interest periods at a rate of interest I per period, is given by S is R times 1 plus I to the nth power, all quantity raised to the nth power, minus 1 divided by I. And a shorthand notation for this is S is equal to R times a lowercase s sub n, and then I like that. There's another way it could be written. So an example, yes. Evie is an athlete who feels that her playing career will last 7 more years. To prepare her for the future, she deposits $22,000 at the end of each year for 7 years in an account paying 8% interest compounded annually. We want to know how much does she have on deposit after 7 years. So R for this is 22,000. I for this is 8% or 0.08. And the number of years for this is going to be 7. So to find this value, S, it's going to be 22,000 times, this would be 1 plus 0.08 raised to the 7th power minus 1, all divided by 0.08. So tossing that into a calculator should make $196,301.67. So Evie has $196,301.67 in her account after 7 years. So the present value of an annuity of payments of $R each made at the end of each period for n consecutive interest periods at a rate of interest I per period. It's given by P is equal to R times 1 minus then the quantity 1 minus I raised to the negative nth power divided by I. So as an example, yes, we want what lump sum deposited today at 6% interest compounded annually will yield the same total amount as payments of $1,500 at the end of each year for 12 years, also at 6% compounded annually. So the n for this one is 12. 12 years, but this is compounded for this one. We are compounding it annually. So this would be 12. And R for this one is going to be 1,500. And I is 6% or 0.06. So this present value is 1,500 times, we have 1 minus 1 plus 0.06 raised to the negative 12th power, all divided by 0.06. And this gives us about $12,575.77. So, a lump sum of $12,575.77 gives the same amount in this particular case. So let me know if you have any questions or concerns. Thank you.